Hi everyone, we're going to look at page 72 and 73. Let's look at question 1. The question asks us, write each percent as a decimal. Draw a diagram to illustrate each percent. 1A says 120%. Okay. Well, first let's look at what percent actually means. This means actually per every 100. Percent, cent is Latin for 100. We know cents, it takes 100 cents to make a dollar. Centimeters takes 100 centimeters to make 1 meter. So this means 120 per every 100. We can write this as a fraction or as an infraction form. 120 over 100. All we have to do now is just to divide 120 by 100. And we know a little trick to move the decimal place back 2 spaces, and this equals 1 decimal 2. It also asked us to draw a diagram. So if I have 100% here, 120 would be a little bit more. Say if I have one whole here, 120% would be one whole and a little bit more. So remember, to convert from a percent to a decimal, we divide by 100. Okay, everyone, let's look at question 3A. It asks, find a percent of each number. Draw a diagram to illustrate. The first 3A asks, what is 200% of 360? Well, let's start off with drawing a diagram. Well, we have 0 to 100%, and we have double that to 200%. And if we draw a number line underneath it, we start at 0 once again, and 100% would be 360. And double that, we can tell from inspection, double 360 would be 720. Well, let's just put a variable here for now, n. Now remember what the percent means. It means per 100. So we have 200 per every 100. And we can set this up as equivalent fractions. So we have 200% of 360. Let's write 200% first. We can write it as a fraction. 200 per every 100 equals n over 360. We know that 100% is 360. Now we can solve for n. Like we said before, we can tell by inspection it's 720, but let's use some algebra. Let's go back to the balance model and use that to solve for n, because it won't always be as obvious to solve for n. So, well, let's rewrite this. And if you remember from the balance model, we need to isolate n. How do we do this? We multiply this side by 360, and we multiply this side by 360. Whatever you do to one side, you have to do to the other side of the equal sign. The 360s cancel, and now you have 360 multiplied by 200 all over 100 equals n. And if you do all these calculations, it does equal 720. I just wanted to remind everyone that when we multiplied each side by 360, I said these cancel. These cancel because 360 divided by 360 is 1. Any number divided by itself is 1. So that's what I meant when I said these numbers cancel. As well, we can simplify here quite quickly as well. What's 200 divided by 100? Well, it's simply 2. 360 multiplied by 2 equals n times 1, or multiplied by 1, but we don't write the 1. So once again, simply n equals 720. Next, we're going to move on to 3b. All right, page 73, 3b. It asks, find the percent of each number and draw a diagram to illustrate. Oh, sorry for the camera shake there. All right, or 3, 2, or double I. All right, 20% of 360. It's asking us to find 20%. Well, first, let's draw a diagram from 0 to 100%. And let's draw a number line below it. We know that 100% is 360. Now, 20% of 100 is about 1/5, so it's approximately right there. So this would be 20%. Now, what is 20% of 360? Where does this correspond to on the 360 number line here, from 0 to 360? Well, once again, let's use some algebra and the balance model to figure this out. So 20% means 20 per every 100. So we can write 20 per every 100 equals, well, we know every 100%, every 100 there's 360. But when there's 20, how much is it when it's 20? Well, we'll call this n once again. And we'll place this here as n. Using the balance model, right now, what we're going to do is once again isolate n. To isolate n, we need to multiply both sides by 360. 360 divided by 360 is 1. Now 360 times 20 divided by 100. Let's use our calculator. 360, I think it's 72, but let's check. 360 times 20 equals, divided by 100 equals 72. So when you crunch the numbers on this side, n equals 72. So then maybe we can write a statement. Therefore, 20% of 360 is 72, which is our answer right here. Okay, we've been taking the long route to explicitly illustrate how we come to the value of n in this case. You'll start seeing a pattern here. In every instance, it's 20, or the percent, the value of the percent divided by 100. 20 divided by 100 is 0.2. Now we can simply just use that information, 0.2, and multiply 360 by 0.2, and that equals 72. But it's important to know the steps as well here. If we look back at question 3a again, what was 200% of 360? Well, 200% is 200 out of every 100. 200 divided by 100 is just 2. And 2 times 360 equals 720. I hope that helps. Okay, let's move on to another question. I'm not going to finish it in its entirety, but I will start you off. So this is once again page 73, question 4. It asks 618 runners registered for the marathon. Of these runners, only 0.8% completed the race in under 2 hours and 15 minutes. How many runners completed the race in this time? Okay, so we are given 0.8% and a total of 618 runners. Okay, we draw our trusty diagrams here, 0 to 100, 0%, I should say, to 100%, and 0 to 618, which is 100% total participants. But only 0.8% completed the marathon. So 0.8 is not even 1%. It's like right here somewhere. So a very small amount of people completed the race. So this somewhere here is 0.8%. And here we have some number that will be proportional to that right here. So 0.8% means 0.8 out of every 100. And that equals, we'll call this n, our unknown, to 618. And I'll let you solve the rest. What's a faster way of doing this? Well, we do know percents. We have to divide by 100. So we could have just done 0.12008 times 618, and that will give us our answer as well. Like I've mentioned before, it's good to see this method because you'll encounter problems that might require this when the problems become more challenging. Hope that helps. Okay, we're on page 76 now, and things get a little different here. Let's look at page 76, question 1. 1A. The question asks us 25%. So we're working backwards a bit here. 25% of a number is 5. Let's draw a diagram to illustrate this more explicitly. So we have 0% all the way to 100. And sure, 0%. Here we have 0 all the way to some number. 25% of a number, 25% of a number is 5. So we don't know what 100% is, so we'll label that as n, but we do know that 25% of a number is 5. Now, we can do this by inspection once again. 25% is 1/4, so 25, this would be 10, 15, the answer would be 20, n would be 20. But they're not, many problems don't use friendly numbers such as 25, 5, and 100. So let's look at solving this using the balance model. But we are going to start with a balance model, but then we're going to show you how to solve this using a different method, the same way that we used unit rates. Let's start with the balance model. So 25% means 25 out of 100, or 25 per 100, which equals some number that we do not know, so 100% of some number that we do not know, over 5. Now, we could remove n or isolate n, but it involves a lot of algebra. Another way to think about this is a unit rate. So for every, let's think about this a different way. So for every 5 we have gives us 25%. Now what would the unit, how much is each percent? If 5 gives us 25%, how much is each percent worth? Well, let's divide the top by 25 and the bottom by 25. So this will give us each percent. So 5 divided by 25, let's use our calculator again here. Decimal 2. Zero decimal 2 over, well, 25 divided by 25 is 1. So we have decimal 2 for every 1%. Okay? Now let's use that to figure out what 100% is. So we have 0 decimal 2 for every 1%. Now what would that be for every 100%? What did we have to do here to get to 100%? We had to multiply by 100. And then we have to do the same thing to 0.2, which gives us 1, 2, which is 20. So in this case, our answer, n, does equal 20. I will do one more. I'll do 1b, and to show you how to find percent, per 1%. It's like finding the unit rate that we did maybe a chapter or 2 ago. Let's move on to 1b. Okay, here we go, 1b. It says 75% of a number is 18. Okay. Love diagrams. They really bring the problem to the forefront. All right, 75% of a number is 18. So 0% to 100%. And we have 0 to some number, 75% of a number. So we don't know what this is. But we do know that 75% does give us 18. Now, what we're going to do now, we're not going to use the balance model. We're going to go straight to figuring out how much is 1% worth. So if you have 18 that's worth 75%, we want to find out how much it is per 1%. So to find that out, we have to divide the bottom by 75 and divide the top by 75. So, which gives us 75 divided by 75 is 1 per 1%. And 18 divided by 75 decimal to 4. Okay, so decimal to 4. Whoops. Now we know that for every 1%, we have decimal to 4. So let's write that down here. Decimal to 4 over 1 equals n over 100%. So once again, to get from there to there, we multiplied by 100. And from here to here, we have to multiply by 100 as well. And decimal to 4 times 100 is, and in this case, let's move the decimal place over 2, is 24. Okay, let's redo number 1, A, and B in a more streamlined manner. So page 76, 1A. And it says 25% of a number is 5. So 25% of a number is 5. And we want to find out what 25% of that number is. So let's change this to 0.25 times some number equals 5. Oh, sorry, the camera is trying to focus on the hand. So let's use the balance model. Let's isolate the number. So let's divide each side by 0.25. And decimal 25 divided by decimal 25 is 1. So we have number equals 5 divided by decimal 25 equals 20. Okay. And let's do 1B in this or the streamlined method, a faster method here. B, 75% of a number is 18. Okay, well, let's change this. They mean exactly the same thing, 75% as a symbol, or 0.75. They mean exactly the same thing, times some number, which we'll use n for this time, equals 18. We want to remove this 0.75 on this side, so we have to divide it by 0.75 on both sides. Well, we want to isolate n, that is. This divided by this is 1, n equals 18 over 0.75, and n equals 24. Okay. Much faster, much easier, but do remember using the diagrams and the number lines will help you solve more difficult problems in the future. Okay, let's do question 3B on page 76. Page 76, 3B. And I would like you to use a similar approach to question 3A. So let's see here. What does the question ask us? It says an elastic was stretched from 10 centimeters to 13 centimeters. And write each increase as a percent and illustrate each answer with a number line. Love number lines, love illustrations. It really helps my thinking. Never hesitate to use diagrams or illustrations. So 0 to 100%. And we have here 100% of the elastic's length is 10 centimeters and 0 here. And we're told that it's stretched an addition, well, to 13 centimeters. So an extra 3 centimeters here stretched, and we need to find out what is the percentage here, the total percentage beyond its original length. All right, so we need to find n%. N%, and if you recall from the first few videos, n% means n per 100, percent means per 100, so n per 100 equals, well, let's write these as percents, equals 10 centimeters over, or under I should say, 13 centimeters. Now, we can solve this really quick with inspection. We can tell, well, what did we have to do to 10 to get to 100? Well, we had to multiply by 10. And whatever we did here, we have to do whatever we did in the bottom, to the bottom, we need to do the top, so 10 times. So we know right away that this n's going to be 130%. But let's use, if we didn't have friendly numbers like this, we would need to use algebra. So let's use algebra once again. So n over 100 equals 13 over 10. Now we need to isolate n. So let's multiply each side by 100. Remember, what you do to one side, you need to do to the other. Here, our goal is to have n all by itself. So 100 divided by 100 is 1. So we have 1n equals 1300. I just multiplied these two, divided by 10, and n equals 130. So therefore, n equals 130%, and the elastic stretched an additional 30% over its original length. I hope that helps. Okay, let's redo 3B another way. So page 76, 3B. We are told that the elastic is stretched from 10 centimeters to 13. 10 being its 100% of its length to 13. Now, let's say you got 13 out of 10 on a test. You received over 100% on the test. If you received 10 out of 10 on the test, that would be 100. But now you're 13 out of 10, which equals 1.3. And if we want to change that to a percent, we just multiply that by 100, which equals 130%. Okay, that's one way to think about it as well. Since I'm doing this, let's do 4. Well, actually 3A. Let's do 3A. 3A. So the house price increased from 210,000 to $225,000. Okay, so this is 100% cost of the house, but it increased over 100%. So we can do 225 all over the numerator over the denominator, which equals, let's see, 225, well, we'll do the whole number here. 225,000 divided by 210 equals 1.07. 1.07. Well, as a percent, this is 107%. So we know, because if it's over 1, well, it's over 100%, so the house price rose an extra 7%.